So, yeah, so hi everyone. We're starting the Chug meeting, and before we get more people showing up, I just wanted to have like a one-on-one talk with Chad about before his presentation. So Chad, let me repeat the question I just asked prior to recording. I was asking you how you've seen people receive, be receptive to the idea of data contracts.
Yeah, so I really started talking about data contracts publicly about a year and a half ago, which is when we sort of finished up our first like real implementation of them at Convoy, and we started seeing the benefits. And there was a lot of pushback. People were not very receptive. I got pushback on everything from the fact that I called them a contract. People didn't like that. They thought it was too much like a legal contract, and there was no real way to enforce these things. And so that got pushed back, and then I got a lot of pushback on just the fact that like producers would never do this, like engineers would never sort of take ownership over the data quality, like that was impossible. And then there are other folks that were saying it's sort of the responsibility of the data team to manage all the quality issues, and if something breaks, like that's part of the job is to fix it. That was definitely where it started, and I would say after the year and a half or so, I've definitely seen a change in people's receptiveness to the idea of a contract. It's gone from, well, I don't think this could ever work to, no, okay, actually there might be something here. There actually might be something here. And a lot of the talks that I have are actually with teams that are either in the middle of implementing data contracts right now, or they have them on their roadmap, and they're talking to me to understand, how do we do it? What's the best way? But they've sort of acknowledged like they're really it'd be very challenging to solve this problem of data quality unless something like a contract or a data API exists.
So would you consider this still leading edge or starting to general adoption?
Oh yeah, I mean, I would say it's definitely still bleeding edge, but I think 2023 is going to be the year that we see many implementations of data contracts. Like 2022 was more about vision, technology, what problems do they solve? Theoretically, how might you solve this? I think 2023 will be much more okay, real implementations, different types of implementations at scale, and people really getting into the nitty gritty conversations on like pros and cons, and where what sort of needed to make a robust ecosystem around contracts and all those types of things. Yeah, I think that's what's going to happen.
Oh, that's really good. Okay, so I guess we're already 10 minutes past the hour. Um,
Mm.
let's just start with the presentation. Maybe give a quick introduction about yourself, and then I don't know if you need to, since we're doing standard Zoom, you should be able to get control or take control and do your presentation, I
Yeah.
hope.
Yes. So I will just screen share here. Can you see my screen, my presentation screen?
I can. Kate, I know, are you able to see things or are you just on the phone listening?
Yeah, I can see things. Yeah.
Okay, there we go.
Yeah.
Excellent, excellent. Okay, so I'll just introduce myself quickly. So my name is Chad Sanderson. I've spent the last 3.5 years at a company called Convoy, based out in Seattle. They're a freight technology startup. It can't really be called a startup at this point, honestly, because they've been around for a while. It's a Series E company. And we've spent a lot of time thinking about data quality at scale, and I'll get into that in the presentation. But prior to my time at Convoy, I was at Microsoft, worked in big data on their, they called it the artificial intelligence platform team. Sounds really cool. In reality, it was just a big data support team for all of the internal products at Microsoft, like Bing, Microsoft Office, Windows. So we provided some of the machine learning pipelines, some of the real-time computation engines, lots of stuff like that. And then before that, I was in big data, although I don't even know if you could call it that at this point, at a few other companies, is Sephora, Subway, Oracle. And then before that, I was in a very different line of work. I was a journalist, and I was living in Southeast Asia, and I did that for like 5 years. So yeah, I've made a transition into very different things. So that's me. Oh, and then also right now I'm running something called Data Quality Camp, and in Data Quality Camp we talk about doing data quality at scale. So yeah.
A good shameful plug.
Yeah, I gotta do a plug. Why not? It would be
Gotta
a
do it.
waste.
Absolutely.
Yeah. All right. So what are we talking about today? So the big themes. The big themes of today are that right now you've got a lot of data teams that are out there, and I experience this as well, that are really struggling to connect the work they do to revenue or margin. And this is a pretty challenging thing, especially as we go through a recession. And I think there's a reason for that. This is a universal problem that's happening on almost every single data team that I've talked to. These types of questions come up, whether you're doing infrastructure or analytical sort of data science work. And the reason that I have observed, my hypothesis anyway, is that the data infrastructure that allows a business to scale from no data to some data that's answering some meaningful questions is pretty different from what's needed to scale to some data to like highly accurate, very powerful, like meaningful data that's used in a machine learning model or any other data product. And those pipelines actually require a pretty different set of requirements in order to be successful. So I laid out a few of those there. Very clear ownership, schema evolution, semantic constraints. That's not the end all be all of those requirements, but it is some of the important ones. So that's sort of the big themes of the presentation here. So this is the TLDR. So if you're a millennial like me and you use Reddit, it stands for too long didn't read. And so this is sort of the summary of the presentation, right? So today, it is really costly to maintain data infrastructure that doesn't appear to be serving direct business value. Now, I think we can all like make an argument about why BI and analytics is obviously valuable to the company. I mean, this is just very straightforward, but I found that for some C-level executives and other business leaders, a dashboard is pretty challenging to translate into a dollar sign, and that makes prioritization difficult. So what we need is to, in addition to BI analytics, to start thinking about data products where the data is generating direct business value. And the way that you get there is through a different architecture. And that architecture requires more software engineering best practices, which we will talk about. And all of these sort of architectural components together is what I call the production grade data pipeline. And the vehicle that you use to initiate production grade data pipelines at source systems is the data contract. That's sort of the data API piece. Okay. All right, so quick, before we get into contracts, just to set the stage a little bit. Businesses go through maturity curves, which I'm sure everyone knows, but sometimes it's good to take a step back and frame. When a company is just getting started, there's no product, there's no marketing, there's nothing, right? It's just existing out in the ether, and they need to focus on the product first. If you have to build something that a customer could use before you can make money from it. And in that V0 process, data really doesn't have much value. And this is why at early stage companies, you almost never see data hires, right? It's all software engineers, and maybe you have a go-to-market, marketing type of person, but never a data person. You start thinking about data, the second phase, which is acquisition. So you've got a product, and now you want to sell that product, and the data team usually comes in at this point as a support system for the product and the marketing team to apply BI, right? How many sales are we doing? What's our churn, et cetera, et cetera. After this, so once you actually have some customers and you're making money, now the question is, are we retaining those customers, and do they like the product? who is using what, how frequently are they buying, what are the sort of primary features that are most valuable to them. This is when we're trying to get a little bit more intelligence, and but still it's a support function. But once we sort of move past solving the problem of retention, or at least, addressing it, businesses start thinking about other things like economics at scale. So optimizing for margin, profit and loss, cutting costs, right? And this is where data doesn't just become a support system anymore. It is the system. Like there's no way to optimize margin unless you have good data. So data sort of takes front and center stage at that point. And once you get into other places like efficiency, sort of reducing operational cost, that's also data front and center. And then finally, sort of at the tail end of a business that's really large, you have regulation, auditing, PII becomes really critical, other forms of governance. And so you can kind of see that if we're looking from left to right, the data goes from not being important at all to being really, 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 fundamentally important as the business matures. So the sort of takeaway here is that when you're just getting started, data teams are not even thinking about scale. They're thinking about support of supplying a little bit of valuable data to marketing and product. So and ideally this data, or not ideally, but it's okay for the data to be directional in this world. So data quality doesn't really have a lot of ROI. Thinking through a comprehensive data model doesn't really make a lot of sense. You have a small team, and you don't need to have all this like big support analysts and data engineers or anything like that. And the processes and tools are all like super scrappy. But once you hit scale where the data is now critical, right? Like when it's serving governance or auditing and compliance use cases, or you have machine learning models built on all this. Now that previous infrastructure that we built doesn't work anymore. It doesn't scale because it is directional, and trying to apply governance and accuracy and high quality to a system that was never intended for that means that all the cost is going to come in the form of maintenance, which is headcount. It's spending a lot on your compute bill, paying a lot for Snowflake. And this is where the ROI gets really questionable, right? Because if we're just servicing these support use cases, but we've got this massive bill and a bunch of teams and individuals and expensive data engineers and architects that are supporting it, I think it's actually reasonable for the company to start to, ask some questions about like, how much value is this actually adding? So in the at scale world, then the directional data is not acceptable anymore. Our scrappy data model that is our foundation doesn't scale. The maintenance cost is enormous, and the data quality is necessary, right? So you have this maturity curve here where I've sort of laid out how the maturity curve of the use cases. And so from left to right, you sort of move from directional data to super high quality accurate data as a requirement. So ad hoc exploration, just shifting through data. Obviously, having more of a prototyping environment is totally fine. But when you're doing financial reporting and governance and AI/ML, that doesn't work anymore. So when we think about data contracts and and I'll sort of get to exactly what data contracts are, but when you sort of think about them in the context of an API, of a production grade system, where might we want something like that? Here are a few of those use cases, right? I already mentioned AI/ML, sort of training data. Something like a data mesh would also require this sort of data API, production grade pipeline. Reports that are or metrics that are embedded in an application. So if you open like Stripe or Robinhood and you see aggregations of data in your account that show you how much you've been spending per month and things like that, a lot of times these are derived on top of the data warehouse. Auditing compliance like GDPR, et cetera, et cetera. Like these are just a few of the use cases, but all of these here really require a different type of architecture. Okay, so high level summary. Data as a support, very important early on. Data as a product, more important later on. Support is all about helping the product and marketing team justifying their own resourcing, whereas data as a product is more about the data generating that ROI very directly. Directionality acceptable in the former, not so much in the latter. And of course, complexity increases with scale, and so does expense. Okay, so we get to the modern data stack, right? What is the modern data stack? Well, if you're familiar with the terminology, modern data stack is all the tools that are built for data in the cloud. So this would be Snowflake, Databricks, all of your ETL and ETL tools that work in the cloud, like Fivetran, Airflow, dbt for CLI, right? Hopefully, a lot of people are familiar with these things, but you know, these were designed to move very quickly and serve that original use case of like just getting started, get some analytics going, get some BI going. So that there's really no governance, there's no sort of quality. Certainly, there's no quality from the producer side here. In fact, the CEO of Fivetran, George, he once said, all you really need in your data for your data pipeline in the cloud is Fivetran, dbt, and Looker. So that's obviously a very a relatively narrow set of constraints, right? Like there's only going to be so much that you can do with your data if you're using that set of tools. So this is great for moving quickly and getting started, but it's really challenging to scale up production grade use cases when you're using this as your underlying infrastructure. So the pros of modern data stack, right, is that it's self-service, easy to learn. It's all SQL, it's Python. You know, most analysts that you're hiring out of school can quickly learn how to use these tools. Which could be a bad thing depending on how you look at it, but it's pretty easy to implement and not super expensive. But then the cons are, like I said, you don't really have great ownership. So ELT in general is plug and play. It's like, hey, I'm going to hook myself up into a production database. I'm going to copy everything in that database and I'm going to dump it into Snowflake. And nobody really ever took ownership of the data and that whole arc of a story. And therefore, you have a lot of garbage in, garbage out. You've got data that was never intended for analytics or machine learning or anything coming into your data lake or your data warehouse, and it gets transformed because that's the only data you have access to. And inevitably, lots of tech debt arises, and you know, it's hard to access the data. Context and semantics are missing, et cetera, et cetera. Right. So this is sort of the cost of that speed. I bet there's a bunch of people who will be watching this that are familiar with this type of setup that I described just a second ago, where you have, you know, some operational use case for the data, some transactional database, maybe it's Postgres or MySQL, MongoDB, or whatever, but that's owned by some software engineer, and the software engineer isn't thinking about analytics or ML. They're only thinking about, you know, their application, and fair enough to them. That's the job that they've been assigned to do. But in the modern data stack world, we just go and we pull this data from these databases without asking 99% of the time, because we need it. And we store all of that data into a lake, which is becoming the more common trend, right? We dump it all in one place. And then we have a set of data engineers that go in and they sort of sift through it and try to clean it up into something reasonable and turn that into a warehouse. And then that warehouse powers all of our analytics. But you can see the little, you know, brown emoji there on the dividing line. Obviously, if the data coming over is not well owned, and then that's your garbage, right? That's your garbage in, unfortunately. And so what happens, to sort of take a more top-down view of this, is that you have this is what I call the non-consensual API. So you essentially have an API, right? There is some schema, there's some data that's being vended by a producer. We're piping that in, but no one ever agreed to do that, and so that means that data can change at any time. Schemas, you can change the schema, you can drop columns, change column names, but the business logic could also change, like, pretty substantially. And this is problematic. And this basically makes ownership of data assets almost impossible, because now you have tables and data models that are built using this data. And if you go to someone and say, hey, man, you know, I would really like to take a dependency on this data mart that you have created in dbt, it's going to be very hard for that person to provide you with a legitimate API, because their response will be, well, you know, how can I vend API data to you if I'm not receiving owned data? I'm not going to be willing to be on the hook for what someone else is doing when they could break me. And so you have this sort of a vicious cycle where there's no ownership anywhere.
Well, so if we can go back to that slide for a second,
Yes.
I like the way you talk about non-consensual API. It's kind of, I can think of a bad joke about it, but it seems that you lose context, that you have your data coming from a source. In that source, there's context, and like, because databases don't track a lot of exterior like data dictionaries and stuff,
Mhm.
that context is known by the local teams. But when we move it to the cloud platform, as you say, you're pulling that data out, you lose that context, you lose some of that meaning.
Exactly. Yes, you're exactly right. And this is exactly where a lot of data teams spend so much of their time, is going and talking to those software engineers to try to understand that context. But the problem with that is when you're spending all your time trying to understand context, and you're not the owner of the source system, then you don't really have an incentive to write that documentation, right? Because you don't own it. So why should you write documentation for something that you don't even own? And so this leads to every person that needs that data going through the same process over and over and over again for every single database. It's a complete waste of time. And I find a lot of data teams are spending, 50, 60% of their time just on trying to get that context. So yeah, I agree with you.
Sure.
Okay, so let's sort of talk about some of our options here. We acknowledge that hopefully we acknowledge this is a bad thing. This is not the ideal state of the world. There's really three options, right? Option number one is we don't change anything, right? We stay the way that we are, and we just accept that only the data team owns quality. No one else does. It's just the folks in data. These non-consensual APIs are part and parcel of doing business. And there are some good things about that, right? It means the status quo is easy to maintain. I mean, that's hopefully self-evident. And I mean, at the end of the day, there's always going to be things to fix. There will always be pipelines to break. We're never going to get out of doing that. So we may as well just accept it, right? But the downside is you will have overwhelming tech debt. Michael, like you said, you will be spending all of your time trying to understand context and semantics, and you won't be able to transition to data as a product, right? You'll always remain in this sort of directional support universe. The next step is sort of process, right? Process only. And by that, I mean, when engineers make changes or potentially might make changes, you include a data team member in the loop. And I actually strongly recommend this. This absolutely is something that should happen. It's a great way for engineers to understand how their changes might impact other teams. It is really effective for like just building the camaraderie and the relationships between software and data. We did this at Convoy, and it's great. The only challenge though is that it does not scale, and this is problematic, right? Because the data team is always going to be, potentially an order of magnitude smaller than the software engineering team, and so we have to replicate ourselves in a million different places. We would basically be in meetings 24/7, 24 hours a day, 7 days a week, just having conversations with people, and that doesn't really work. So what I recommend is a combination of process and technology. And so data products are kind of the answer to this. This is a shift left data quality or shift left data ownership. And the idea is you fit into the existing engineering workflow. You use all the tools they're familiar with, GitHub and Kafka or Kinesis and Airflow and all of these things, Protobuf. And it's decentralized, meaning it can be handled between the producer and the consumer, and you don't need the data engineer as the middleman. They can focus on what they do best, which in my opinion is infrastructure, but maybe there's something else data engineers want to do. And like I said, it's a combination of the tech and also the process. How do we work together, and how do we use the tech to make that process more efficient? The downside here is, like, obviously it's expensive to implement, so it's less of a scaling problem like the process, but there is sort of an upfront implementation cost. Okay, so when we're talking about data as a product, what do we mean? Data as a product basically means you are treating your data as a value generating service with all of the standard software engineering best practices. You're using APIs, CI/CD, monitoring, version control, and so on and so forth. And sort of the themes of data as a product is you have to be decentralized in the same way that like a product management organization interacts with the software engineering team, the data organization interacts with the software engineering team. You should be following the existing standards. And this is a really important point. Data products are a subset of all data, right? So I try to communicate this. A lot of people still don't get it. You don't need, not everything is a data product. So that means you don't need this type of infrastructure and governance and CI/CD and everything else. You don't need that everywhere. That's a big cost. And you have to be willing to pay the cost in the places that it matters. So we'll talk a little bit more about this, but so and by the way, Michael, you just stop me at any time, right? Anytime you want to talk about something, just let me know. I'm happy to, go back and forth on
Yeah,
that.
sure. I mean, Kate, if you have a question, go ahead.
Yeah,
Yeah.
please.
So I think I really like the way Michael comment on the context before. And Chad, you say that you advocate for data as a product. So can it solve the context problem before?
So we are actually right about to address that. So there's a box
Okay,
on the
that's
left
great. Yeah.
talking about
Yeah.
context.
But I was gonna say,
Um,
Chet, that you made a really good point before you go on about
Yeah.
data products are a subset of data. Because I always look at data as data. And when people say, oh, we gotta make a data product out of it, like not everything fits into that data product. And like you'll
Yes.
have a lot of operational data that you generate and work with that you need, but you'll never turn it into a data product for adding value.
Exactly.
So I think that was a very, very key point. I'm sorry, go ahead, please continue.
No. And yes, that is a great point, and it's something. It's a great call out, and it's something that I think requires a bit of a mental shift, especially for those of us that have spent a long time in the BI and analytics space. Because I think to us, it's like, yeah, we look at all data sort of equally, but in the data products world, that's not the case. Like you might have one or two data products at a company, but those two data products might be making millions of dollars for the business every year, and that requires a lot of cultural change to take advantage. Okay, so when we're talking about the programmatic piece of this, I'm not going to dive into too much into specific tech. We're just going to talk about requirements and what really needs to exist. So I think about it as really sort of three key parts of solving this problem. The first is producer awareness. And what I mean by that is when most data producers today, whether they're software engineers or somewhere else that's doing, like a Salesforce administrator, they're not aware of how the data that they generate is being used. They're clueless, and it's not their fault, right? It's not their fault because of all these modern data stack things that I talked about before. But in their mind, they're just making changes to their transactional systems, and the data is poof, it's sort of disappearing. It's going into Snowflake or Databricks or Redshift or wherever, and they have no idea what happens to it after that. It just disappears. So in order for us to get these data producers to start thinking more in terms of APIs, we have to open up that black box. And that means being able to communicate the semantics of the data. What does the data actually mean? What are the dependencies? Meaning, if someone owns a database, what are the things that they, if they change, that they could potentially impact that actually have a business value? Right? Your producer needs to be aware of that. And they also need to be aware of the context on both sides. So both on the producer side and the consumer side, the producer needs to understand, if I drop this column and I break this data product, what happens? Is this a SEV 0? Is it a SEV 1? Do we lose $1 million? Right? If they don't have that context, then they don't have all of the tools that they need to be able to make these decisions in a feedback loop. The next piece is APIs. And APIs, everybody understands APIs, but that's great ownership, abstractions. So not reading directly from the database and piping internals into your data lake. It's having something in between that gives the engineer the flexibility to make changes to their applications however they want, but still fulfill the contract, so to speak, in some abstraction layer. SLAs, and some of those SLAs could be, freshness. It's not always the SLAs that we think about when we're talking of APIs. And of course, documentation and context is a big part of documentation. And then the last piece is enforcement. So once we've said, hey, this is the data that we need, this is the shape we need it in, this is the SLAs that we need, then there needs to be some sort of mechanism of ensuring that if there is a contract violation, number one, we're cataloging that. We're sending a message to the appropriate team, and we are updating our SLAs accordingly. And depending on where you want to enforce these APIs, it might require a different solution. So if you want to enforce them in the CI/CD layer, then that's going to be a different technology. If you want to enforce them sort of between a production system and a data lake in a stream processing layer, that's a different technology. If you want to enforce them from table to table in the warehouse in batch, that's a different technology. But so the point is, don't be super attached to the technology. Just think about where do you actually need these APIs, and then sort of reason backwards from that. So I sort of talked about what the old world looks like, where you have all these non-consensual APIs. On the right, I have my view of the new world, where at the top here, we have our database, and there is a contract or an API that defines what is the data we are expecting and what is the SLA around the data. There is an expectation on top of the target. So there should be something that says, this is what I expect my data to look like, and I validate that data as it comes in. And if ever those things don't match, I push the data out somewhere else, I filter it, whatever. Obviously, filters are not ideal, and we need to fix those, but there should still be some expectation in place. And then there's another contract between that data model and whatever the final data product actually is. And then there's an expectation on the final data product. And so in this way, this is what I would call a production grade data pipeline, but very simply and high level. Okay, so I've sort of used the term data contracts a bunch of times, but I want to actually define it and talk about exactly what it means. So data contracts, API-based agreements between producers and consumers, which capture schema, semantics, distributions, enforcement policies, privacy, and anything sort of related to the data that can or should be programmatic. The sort of last line there in bold is the critical point. They're the technical vehicle that is necessary to roll out data products. They're just APIs. Think of them like APIs for data is the best way. There's a few things that are really good about data contracts that have served a lot of value at Convoy and other places I've seen them implemented. The first is that they're a single surface for collaboration in a shared language, meaning that a data consumer can say, hey, I've got a contract. You can push that to a data producer that reviews that contract. No longer are you speaking, one team is speaking in SQL or metrics or dashboards, and another team is speaking in, databases and MongoDB and whatever it is that they're using, right? You have a single surface that they can collaborate on. It allows your data model to evolve iteratively and in an agile way. And what I mean by that is, if you're able to establish a data contract or this sort of iterative governance on a sliver of the problem, so not rolling it out to every single data model or schema in the entire company, it's much easier by building that relationship with the producer to add on more, better modeling over time. Hey, now I would really appreciate if we added in this foreign key. I'd really appreciate it if we added in this dimension. Those types of conversations become a lot easier once you've established that first context, contact. Okay, so some of the tenets of data contracts. So these are things to keep in mind. In my opinion, all of these must be true in order for whatever your solution is to be a true data contract. The first one is enforced at the producer level. If there's no enforcement, then it's just monitoring. It's not a contract, and that's fine. Like, monitoring is good. There's nothing wrong with that. But contracts is about enforcement. Someone has to be willing to take action. Programmatic action is great, but there has to be something that's sort of pushing that action to be taken. They must be public. We already talked about APIs, version control, change management, etc. They have to cover the schema. The schema is the most foundational aspect of the contract. There's a lot of people who have already figured out, schema management and schema evolution at their company. That's great. It doesn't mean that you have a complete picture of the data contract, because you also need the semantics of the data as well. And you also shouldn't be impacting iteration speed. This one is more of like a nice to have, but I still strongly recommend it. If you are negatively impacting developer velocity, it will be very challenging for you to roll out data contracts.
Okay, so if we can just go back to one slide.
Yes.
So we talk about producers.
Yes.
So that could be all the way back at the source system, or it could be a producer as you drop the data, and I know you use the term ELT, but ETL the data to your data lake. So once
Yes.
it's the data lake, from that forward, would that be another producer?
Yes. Yes. My definition of producer, which I realize I probably should have clarified, is really is anyone who's providing some sort of a unique transformation to the data. So if obviously, like you said, if you're the actual producer and you own the source system, you're definitely a producer. But if I am, a data engineering team that is aggregating that data in a data lake, I'm turning it into a data mart, I'm also a producer, and I should probably have a data contract with my potential, internal customers. Okay. So this is sort of a high level of what a data contract looks like. It's basically, what I just said, where you've got sort of the contract on the left there, schema semantics, any other validation you want to perform, SLAs, and then some form of validation, some suite of tasks that validate that contract in flight. And these could be, a variety of checks and monitors. Okay, so where do you apply contracts? I mentioned this before, but my opinion is that contracts should apply at every data handoff. So you can think of, our data pipeline as, I don't know how many folks watch the Olympics. I'm a huge fan of like the 4x100 relay. And, you've got one guy running, like Usain Bolt is running, and he has the baton and he passes it off to the next person. That's kind of how I think about the data pipeline. And at every sort of stage in that handoff, you need something to ensure that the person receiving the baton knows exactly what they're getting and they know when they're getting it, right? So any meaningful transformation, anytime data changes hands, I think it's pretty important to have contracts there. Now, I do think that it's most important to start at the source system. And I'm pretty sure I'll get into this a little bit later, but basically, if you try to start in the middle, it's very, very challenging because there's no contracts anywhere else, right? So asking someone to take ownership of something before the source system has done it is always a bit of a recipe for disaster. You can enforce contracts anywhere. There's sort of three main types of contracts, I think. There's enforcing in the CI/CD workflow. So this is breaking changes before they actually happen using some schema registry. There's in the stream. So this is as data is moving from point A to point B, ideally at the row level. Maybe you're using something like CDC. You're running checks on each row. And if that check is violated, then you're alerting on that. And then there's the batch checks, and generally you should do batch checks for looking at aggregations of data like distributions and significant shifts in distributions over time. So I look at the contract as really a two-part thing. The first is that it's supposed to keep stuff from breaking, and then the second part is that if things do break, it's supposed to detect that and alert the relevant personnel. And generally, this is the producer or whoever it is that has taken responsibility for the contract. So for the prevention side, this is in the developer workflow in CI/CD. It involves taking defining the schema, storing it in some sort of registry. At Convoy, we use the Kafka schema registry for that, but there's a lot of other tools you could use. You could use GitHub for that if you want. And in the event of a violation or backwards incompatibility, then you are breaking the build and you're surfacing something then to the software engineer on the awareness side. I mentioned this before to help them understand what was the thing that I broke, or what was the reason that my build was broken. What is the contract? Who is the person that owns it? What is the context around this? And that informs, the direction that they take next. Something to keep in mind here is I don't see data contracts as a wall, and a lot of people do, right? They think of contracts as like, we've got a wall in between our producers and consumers, and nothing can change once we add a contract. I don't think that's the way to do it. I think it's best to think about contracts as a feedback loop between producers and consumers. So it's ultimately up to the producer what they choose to do, like what API they choose to build. That's their choice. But you want to give them all the context as you possibly can to help them make that choice. And my hypothesis, and I haven't been proven wrong yet, is that software engineers are not bad people. If you give them the context around these around like what a break in the pipeline could do to the company, they're not going to make a decision out of spite. So this is a big part of the preventative side is, and I believe that using things like data lineage and doing diffs between like what does the data look like today, and if we ran some test data like 2,000 rows of data through our new pipeline, what could it look like tomorrow? All of these are tools that the engineer can use to understand how bad a violation is going to be. One more thing I'll sort of say on that point is, and this is the point of like not everything deserves a contract. In the same way we have contracts, not everything deserves the same level of adherence to the contract, right? So you might have a contract on a dashboard for a C-level executive, and that dashboard could be very important. But if the software engineer needs to make a breaking change because they're going through a big database migration or a monolith decomposition or something like that, they might just say, look, I'm making this change. I know I'm violating the contract, but when I do, like I'm communicating that change out to you. You can roll onto the previous version when you're ready, and you have all the context. That's like one form of contract violation. But another form might be, our company is a I don't know, it's like a flight recommendation system, like or like Kayak or booking.com or something like that. And if you make a change to this particular database, you will break our entire model. That's like a very different level of contract, right? That's something where the business might say, you can't make changes. You have to ensure that the contract is adhered to before you push your changes out. So that's what I mean sort of by prevention and awareness. Okay. So when we talk about what a preventative system might look like, here's a very high level architecture, right? And it really just sums up what I said. You sort of have the CI/CD workflow there in the middle. There is at Convoy, we defined our schemas in Protobuf. Those were stored in GitHub. And then during the testing phase, there's backwards compatibility checks. We ran compatibility checks on the contract to see if the new version of the contract was backwards compatible, and we ran these backwards compatibility checks on the data itself. So we used Docker, spinned up a copy of the database, and then checked the data. And if both of those checks pass, then we would publish the new schema back to the Kafka schema registry, and the build passes. And if they fail, if any of the checks fail, then the build fails and they get an alert. Okay, so for detection, it's a little bit more complex, right? Detection and thinking about semantics is more rich. There's a longer tail on how you do this properly. So there's a few type of checks that you could run. The first is schema checks, right? This is sort of the most obvious one, so I don't need to spend a lot of time talking about that. But this could also be things like, did the, are there null values, right? We expect that some column is always going to be null. Is it actually null? That can be specified in the contract. And there's a long tail of sort of values we care about, value constraints that we might look at. Like we have a tax identification number, and that always has to be 10 characters long. And if it's not, then that's a problem. When we talk about semantics, really what I mean there is the relationship that data has to itself and to other entities. I was chatting with one of the principal engineers over at Chewy a few days ago, and one of his issues that he mentioned was at Chewy, you can, there's like a pet food company, and you can tell them, hey, my pet is a dog. It's like a German Shepherd, and it's 4 years old. And depending on the age of the animal, Chewy will make recommendations to send different types of pet food, right? A dog that's 8 years old could be in the prime of its life, or it could be near the end of its life, depending on the breed and other things. And sometimes they would get back data that just didn't make any sense. So they would get back data where it's like the pet food that the last pet food that they sent over was dog food, but now the animal type is like a snake, right? So that's a good example of where the semantics don't make any sense, and obviously whatever automation or machine learning is, whatever outcome of that is going to be wrong. Cardinality is another one. So this was a really important thing for us at Convoy, where there needed to be a many to one relationship between shipments and shippers. So you're never, or you should never have a situation where the same shipment is being put on the market by two different shippers, right? So we need some mechanism of ensuring that never happens, and if it does, we treat it like a regression. And then we also have distributions and SLAs. So distribution could be something like, I always expect this particular field to have a normal distribution. And if it has a bimodal distribution, something is very, very wrong. So that might be something an engineer could take a look at. And then SLAs, you can do freshness checks like quite simply using this model. And in terms of, and really quickly, so how do you do this type of detection? Well, like I mentioned, it really just depends on where you're trying to catch issues. At Convoy, we had a stream processing layer. We use Flink. As the data was moving between Postgres and Snowflake, which is our data warehouse, we had a YAML file that was defined by our consumers that contained all of the checks. We would run those checks at the row level, depending on exactly what they were. And if we caught any violation, we would stick that into a DLQ, and we would send a Slack message to whichever engineer was responsible for the contract. Some of these things you can run, you can only run once the data hits the warehouse. Like some of the distributions are an example of that. So there's tools out there, right? Light up data, Monte Carlo, Elementary, I think, is an open source sort of monitoring tool. You can run this on top of these things, and you can run these checks yourself, like quite simply. So tying it all together, right? You've got a contract stored in a schema registry somewhere. You've got a set of checks that run during CI/CD, and if there's any build breaking issues, then you do that. You implement a lineage system so that you provide context for producers so they understand, hey, what is this data? Where is it being used? How is it being used? If you've got a stream, if you've got an event stream and you're using Kafka or Kinesis, you can define your contracts in YAML, you define your checks in YAML, and then they run in some stream processing layer by like Flink or KSQL, although I think KSQL might be getting phased out soon given the recent acquisition of Immerok by Confluent. And then in batch, you can define monitors in either SaaS or open source tools. And if you detect a violation, then you can roll back the data models to previous versions. And then ideally you have a catalog that stores all this information, right? So you have a place where you can see, here's my contracts, here's the semantic objects that those contracts are tied to, and then here's all the data that I just shared, right? Here's where they're, here's the schema, here's where it's stored in our schema registry, here's the all of the violations of this contract, and here's the final, set of tables where the data actually manifests either in the lake or the warehouse.
Which have you worked with a catalog, like for example, Data Hub or any other catalogs out there to implement basically a storage or registry?
So at Convoy, we built this ourselves, which I don't recommend, but we built this ourselves just using a pretty simple React application. We started off using a read tool and just basically aggregated all these sort of data sources together and put it in an index. But Data Hub, I've heard, is super, super flexible, and it's very easy to add new nodes. So they use like a graph, and all the nodes that get indexed are, so you have like metrics, and that can be a node. And here, like contracts could be a node on a graph. So I know Shashanka is thinking a lot about that. He sort of is the one in charge of Data Hub and the hosted product, whose name I forget. I think Acrodata is what it's called.
Acrodata.
Acrodata, yeah, exactly. So
Yeah.
Data Hub, I think, is a good option, but it's also something you can build yourself quite simply if you wanted to.
Yeah, I'm a little skeptical of Data Hub for this, as far as acceptability,
Okay.
but that's just my take.
I don't know.
on it.
I've
Anyways,
never used Data Hub, so don't take my word as gospel on that one.
No, yeah, I think honestly, I think the enterprise data catalog space itself, is very immature, considering how long it's been around. I've had one friend tell me that he heard from one of those think tanks that you shouldn't invest in data catalog, just do whatever you want, like a spreadsheet or something, because the market's still not there yet, or the products aren't still there yet. So
Okay.
Just take it with a grain of salt, but yeah.
I could believe that. I mean, ultimately, that's what I did, right? So I can't I can't refute that point. Yeah. So but in my for something like this, like I said, in my opinion, there's a bunch of tools out there where you can do this yourself. For example.
Yeah.
Question that folks might be having as they're watching this is like, all of this sounds well and good, but ultimately I need to get my engineers involved in this process. And how do I do that? How, are they going to be willing to just start doing all this extra work all of a sudden? I don't think so. It's important to think about what the incentives for the data producers actually are. And if you understand their incentives, then you can make the process of owning this upstream data way simpler and way easier. There's sort of three key points that I always like to call out. The first is make it simple. If you have to add in a bunch of additional tools that they're not used to using, or there's brand new workflows and processes that they don't have to do today, then there's going to be resistance and there will be friction. So one of my sort of guiding lights when I was rolling this out at Convoy is I wanted them to use their exact same tool stack that they do today, and solving sort of a bug in data should look virtually no different than solving a bug anywhere else in their application. The next thing is awareness, which I already mentioned. We talked about that a lot, but something to call out is the tactile feedback is super important. So this means that when an engineer is in their development workflow is when you want to give them the feedback that they might be violating a contract, and then give them the context of what they're implementing. What you don't want to do is wait for a week, right? They've rolled out a change, and then a week later you say, oh, the data is wrong, and I need you to go back and fix it. Like, they've already moved on. They're working on something totally different, right? You have to get as far left in the feedback loop as possible. And then the last is, it has to be high ROI. So that means they need to be working on things that add a bunch of business value to the company. If taking ownership over a column or a schema is super critical, they like that, right? Engineers like maintaining valuable systems. It looks good for their career, it looks good for their product organization, and it just makes them feel good and makes them feel important. And that is why the other reason data contracts shouldn't be applied for all data, just for the data products that actually matter. And if you have the whole system that I just described, and you have these sort of feedback loops in the CI/CD phase, and sort of in the monitoring, being able to monitor data in a stream processing layer, you've got the tactile feedback. If you focus on data products, and you've got the high ROI. Okay, so in terms of realistically what something like this could look like as you roll it out in your company, I try to say, like, temper your expectations, right? Don't sort of go into it thinking like, oh my God, I'm gonna have all the data that is meaningful to me under contract with a million different constraints. Like, this just doesn't really work that way. You don't want to overwhelm people. There is sort of like a human psychology theme to all of this, where people need to gradually dip their toe in the water, feel that, like, okay, managing data, not that bad, not that different from any other API. I can do this. I can take on more stuff, right? That's sort of the feeling that you want to create. And that starts with awareness. And that's just like lineage, right? It's just showing software engineers, hey, here's how your data is connected to my data. Here's how when you change things, it affects me. That's a really good starting point. And then ensuring that that is very visible for them. The next step is the actual ownership of the contract, right? So this is, hey, I'm willing to now be responsible for a schema or a table or a couple columns or something like that. And I'm willing to be on call if this goes down according to the constraints of the contract. The next step is the API. So this is like really getting into the CI/CD workflow, specifying clear inputs, outputs, and having abstraction layers, and doing great documentation and version control and everything else. Although oftentimes I have found that engineers actually want this API step sooner rather than later once they start this whole process. And then the final piece is the actual rules. So it's the constraints. This is the piece that most software engineers are the least used to, because they're just not thinking about taking action on data in this way, right? They're not thinking of saying, oh, well, the distribution of data looks wrong. I should go and fix a bug. That's something that has to be introduced gradually. And I recommend starting with simpler things like constraints on, on values. Like I mentioned the tax identification number before, but that's like a great starting point, and you can always become more sophisticated over time. I think we're almost out of time here, so I'm just going to fly through these last few slides if that's okay, Michael.
Time is up to you. If you've got the time, great.
Oh yeah, I do. Okay, cool. I'll go through it then.
Yeah.
So where do you start? Where do you start rolling out something like this? My rule of thumb was choose a use case to begin where incremental data quality means incremental business value. Okay, and so what I mean by that is if our data becomes more accurate, we can very cleanly and clearly tie that to a dollar sign. That's the ideal. Or you can tie it to a cost savings, or you can tie it to a person savings. But there's some very tight link in value there. So as an example, when we were first getting started this at Convoy, we focused on our pricing model. And the way that our pricing model, Convoy is a freight brokerage company. We have a marketplace. And what we would do is when we had the opportunity to put shipments in our marketplace, we would run this model to figure out what we think the ceiling and the floor is going to be on that auction. If it's a very high ceiling, that's great because that means that Convoy makes a lot of money, right? If the market is up and people are bidding very high to take these, or sorry, it's the opposite. If they're bidding very low to take the freight, then that means Convoy makes significant margin. But if the market is bad and truckers are bidding very high, so they're saying, look, I'm not going to take this shipment from Atlanta, Georgia to Tampa, Florida for anything less than $5,000, then that means the amount of margin that we make is very low and potentially could even go margin negative. Now, the inputs to this model were shipment data, the shipment opportunity data, there was data about our previous auctions, and just data about general behavior in the marketplace. And we had run into a lot of issues where upstream, producer where problems coming from our source systems caused that machine learning model to fail. And we retrained the data every single night. And so we could have potentially an entire day of bad data that would really bias our model for the previous day, for the following day. And there's a bunch of use cases for that. There's a bunch of use cases where that happened, and it got to the point where almost every month there's a period of like 6 months, almost every month we were experiencing another COE. So if we can go into that use case and say, hey, let's identify where we need contracts, right? What are the sort of upstream sources where we need contracts, where if this data didn't break, it would make our model better, right? Let's start small, and we can even start just with IDs. We can say, hey, I always need this shipment ID to be non-null, right? If I can do that, I know that's going to improve the quality of my model by 5%. I'm going to have 5% less nulls in my data, right? And that's where we started. And there was a clear mapping because there was actually a ground truth, right? Because someone would eventually, there would be a real bid price. So we would essentially measure the final bid price to our prediction. And if we became 5% more accurate, then you could measure that in terms of dollar value back to Convoy. So that was a really great place for contracts. It proved out the concept and it showed to the business like why data quality is important. It's not just to make us like data engineers feel good about ourselves. It's actually to make the company money. Yes, so that's where I recommend starting. And then, oh, sorry, go ahead, Michael.
No, I was just going to say, when I started thinking of where and how to start, there's a question of, again, you beginning this talk, data, this whole thing, data contracts is leading edge, bleeding edge. So if I were a company, where would I start to look to learn more about data contracts? I don't think you've written a book yet, have you?
No, I haven't written a book yet. But yeah, little teaser there. But I do have a Substack, which is dataproducts.substack.com. Or you can just type in like Chad Sanderson Substack on Google. And I think I've got like 4 or 5 articles on data contracts out that are I think have been established as the primary data contracts canon. So we cover how you roll out data, like number one, what are data contracts and why are they useful? How do you roll out data contracts on databases? How do you apply data contracts for application events? And how do you do data contracts in a data warehouse? Definitely more to come. But if you just want to start like reading and understanding how you might apply these from like a technical perspective, that's where I would suggest getting started.
That's perfect. I mean, like I said, it's just getting the idea of expanding on what you've said here today. I think that's important, and I think that's great.
Yes. Yes. Um, okay, yeah. So when you're just starting thinking about this, this is sort of the focus, right? So when you're just starting, the focus is just making people aware. Like I said a bunch of times, you're thinking a lot about data quality, tying yourself, ideally trying to couple yourself very tightly to dollars and cents, keeping it simple and being incremental. But once you've sort of started to mature and you have a bunch of data contracts in place, and everything's going great and you've got collaboration and all these other good things, data contracts can now take you in some really interesting directions. You can do better data modeling, as I mentioned. You can have clearer ownership around entire domains and business life cycles. It pushes the business towards an event-driven architecture because, in fact, at Convoy, the biggest consumers of the data contract were actually other engineering teams because of course, like other services want access to very high quality data that is semantically clear with constraints in place. Data mesh, right? Data mesh is super popular as this like organizational framework. I personally think that I'm not sure how you would implement a data mesh without data contracts as a stage one. Just not sure exactly how that would happen. And also just being sort of generally comprehensive about your data architecture, ensuring that you're capturing all the right data, the right events that are most meaningful to the business. That's sort of another use case. Impact at Convoy, I kind of talked about that a little bit already. We rolled out hundreds of these contracts, and it like my primary my KPI when I was going through this effort was I wanted the producers and consumers to talk to each other about data. That was like my number one goal, and I felt if that happened, even if data contracts as a technical mechanism was a complete failure, if I could just get people to talk to each other about their data, then that was a win for me, and that's exactly what happened. You were seeing these big threads in Slack where a data producer, a software engineer, would go to a team and say, "Hey, I have this contract. I was thinking of changing it in this way. Like, does this impact anybody? Like, what's going to happen if I do this?" Or do you have consumers suggesting things or asking for things? And the coolest thing for me that I saw is that in the later stages, it actually flipped. That you would think that all of the contracts are going to be driven by the consumers, but it actually reversed where engineers were going to their consumers and saying, "Hey, what type of contracts can I give you? Like, what data can I provide you to make your life more useful?" Because they started to understand how valuable the data was.
So how does
Yeah.
lineage, sorry, let me ask you real quickly, how does lineage play into your data contract? Because you start talking
Yes.
about consumers, producers. If I'm a producer, I have to look at lineage to see who my consumers are,
Correct.
like a reverse
So
lookup, I guess.
yes, yes, exactly. You got it. Reverse lookup. So the system that we had, here's the way that I thought about it: is you basically have some mechanism for a consumer to define their contract. That's another important point. It's actually a critical point, and I didn't even put it in here, which is kind of insane now that I think about it. But I think that this system only works if it's consumer driven. So consumer driven data API is not producer driven because consumers are the ones that know what data is important and what it means to them. So we had there's basically a mechanism for a consumer to define their contract through a YAML file. They would specify the schema, all the semantics of their data, what each individual column meant, what a row, what an individual row represented, the constraints. All this metadata got stored. It was dropped into a central data platform repository, and then we ran reverse lineage from the bottom of the graph up to the top to the source systems. There's a mapping between the source table and whatever the producer system was, and then we took out a PR against those repositories. And so basically, you say, "Hey, I need this contract." and boom, we run lineage. The contract gets requested. The engineer either accepts or denies it, or wants to have future conversations. And then the next time that they go to make a change that could potentially break the contract, they have all that context. They have the lineage, they have the SLA, they have how the data is being used, they have the owner, and then they can make a choice, right? They can make the choice to say, you know what, I don't care about this contract, screw you, I'm going to break you, it doesn't matter to me. Or they can say, yeah, this actually seems important, I'm going to go and talk to this person. And then the business can decide sort of the level of governance they want around contracts. So the business might say, oh, this is like I mean, I haven't implemented this. I'm sort of talking theoretical here, but the business could say, hey, I've got a gold standard contract, and those are for our tier 1 services that make us money. You cannot make a breaking, like we will not allow you to make a breaking change to those contracts. If it's a bronze contract, you can make a breaking change, but just be aware that you're going to be the one on the hook if this turns into like a bigger problem, right? So yeah, that's how I thought about lineage. That answers the question. So yeah, key takeaways here. We're almost done. I promise. This is the last slide. Once the data team reaches scale, there's a ton of value in switching thinking to data products. This allows the data team to say that like, hey, our data is generating value. We're not just a support team. All of this infrastructure and all this personnel actually makes sense because we're making money for the business. The infrastructure that is required to scale that is different from our sort of initial BI and analytics infrastructure. And I call that the production grade data pipeline. And data contracts are a really key piece of that. They're data APIs. They cover schemas and semantics. They can be enforced in a variety of different locations, CI/CD, batch, and streaming. And the thinking is to decentralize and to invest where incremental improvements in quality result in incremental business value. And that's it. That's my presentation. You know, I mentioned the data quality camp Slack, so that, you know, I'll sort of plug it again at the end there. And if you ever want to talk to me, just look me up on LinkedIn. I love talking about this. Like, I legitimately love it. I could talk about it all day. So feel free to reach out anytime.
Yeah, Chad, thank you very much. I'm going to stop the recording now since we lost Kate. So, but no, this was definitely a great presentation. I can tell you're extremely passionate about it, which is good. So hang on, let me just stop the recording.